by three excellent panelists, and I'll allow them to start off by introducing themselves and tell a little bit about their organizations. So why don't we start with you, Jason?
Hey, thank you. So good afternoon. My name is Jason Rondu. I'm with Los Angeles Department of Water and Power, and I think many of you have heard of us, but for those of you who have not, we're a municipally owned utility in Los Angeles. We're vertically integrated, so we own or control the majority, close to all of our generation. We own transmission, and we even own and can design, build, and engineer our own distributed resources, including solar, and we're working on some microgrids. I'm currently responsible for our distributed energy resource groups, our local solar groups, our feed and tariff, our demand response, and then I'm also responsible for our entry into the energy imbalance market that we plan to do in 2021. And LA is facing a number of really unique challenges, and I'll kind of touch on that probably throughout the panel discussion, but earlier this year it was announced that 1,600 megawatts of local gas-fired generation in the city of Los Angeles, we will not be repowering. So in 2029, we need to replace 1,600 megawatts of base load energy. And what that's going to mean is a massive, massive growth in distributed resources. So to the degree that we can control those, that we have visibility in them, is going to be extremely important for us to maintain reliability. And just to give a sense of the magnitude of what we're dealing with, we're losing 1,600 megawatts of base load. Our peak load is about 6,500. And so we're losing 15, 20% of our load. And to replace that, some preliminary studies that we've done have said that we'll probably need nearly 2,000 megawatts of local energy storage in addition to solar, in addition to demand response and other distributed resources. So that's really what we're up against, and we're going to need to do that in short order here.
Great.
My name is Adam Todorsky. I'm with AutoGrid Systems. AutoGrid provides software as a service to utilities, both regulated and deregulated, to solve some of the problems that those DERs coming onto the system can cause, or turn some of their challenges in how they operate into opportunities. So we apply big data and machine learning algorithms to figure out how to solve for some objective function the resources you have on your system. So with battery storage, distributed generation, demand response, resources like that, you might have, if you're a wires utility, if you're responsible for the distribution management system, for example, you would use our platform to solve for maybe a current limit at a substation or feeder or something like that. And the platform would do that by figuring out how much flexibility it can get from a given resource at a given time and come up with either a merit order-based dispatch, or maybe you might have some overriding rule that you're going to apply to accomplish that. I'm getting into the nuts and bolts of it a little bit, but the reason I'm doing that is the title of our panel is DERMS and VPP. So these are two sides of the same coin that are very different. So that's the wires side of it. The VPP side of it is, I don't care about the wires, I just want to make money. And that's the other clientele that AutoGrid serves with this same platform. So if you're, instead of solving for, I want to limit current through a feeder, you might solve for, I have this commitment in a market, and I also have these other value streams that I'm trying to achieve with these resources. So I need the system to calculate when the batteries need to charge or discharge or whatever to, or even just loads turn on and off to achieve that. So in a nutshell, that's what AutoGrid does. As far as me personally, at AutoGrid, I manage our product technology for our commercial and industrial and market-facing control integrations. And I have a background working for demand response aggregators doing ancillary services and in-front-of-the-meter battery storage.
Great. Takanori?
Oh, thank you. I'm Takanori Tomozawa, now visiting scholar of the Stanford University, and originally from METI. METI is acronym Ministry of Economy, Trade and Industry, one of the Japanese government organizations. METI is a very big organization combining Department of Energy, Department of Commerce, and Small Business Administration, and some patent office. And I'm almost involved with energy policy And before coming to Stanford University, I was leading the revision of the strategic energy plan in Japan, like a vision in 2030, strategy to 2050. And in the strategic energy plan, it was decided that the government must make the renewable energy the main source in the future. And the VPP and the DERMS is a very important part to do this. So we are now discussing some demonstration projects of the DERMS over some virtual power plants, and we try to rebuild the regulatory framework for the virtual power plants and DERMS. So, yeah.
Great. And so we've thrown around the term DERMS a lot, and I think an important way to start this panel is to set a baseline. So I'd love to hear each of you talk a little bit about kind of how you or your organization defines DERMS, and additionally, how does your understanding of DERMS influence your strategy? So maybe Takanori, we could start with you. With how has your time at METI influenced how you define and see DERMS?
Okay. Honestly, the word DERMS is not familiar still inside the Japanese government. So we are now more focusing on the VPP, so virtual power plants. So, but under my understanding, so virtual power plants is focusing on the balancing the supply and demand, and the DERMS is more focusing on the voltage management or some flow of the electricity and the distribution level. So, and about VPP, we are now discussing about the imbalancing market formulation. So 2021, the imbalancing market will start. Yeah, there are many regulatory framework changing in Japan. So 2016, the liberalization of electricity happened. And 2017, we made the rule of the demand response. So recently, demand response by the virtual power plants have happened in the heavy weathers like hot summer and cold winters or something like that. So we are thinking the DERMS is the next step, and we are now discussing the demonstration projects of the DERMS. We are now communicating with Ministry of Finance to get the budget. So yeah, we hope in the future something happened. Yeah, something will happen.
Great. Adam, do you want to share your perspective of the definition of DERMS and how it's informed your understanding of the market?
Yeah, so by way of introducing AutoGrid, I described my own thinking of how you might define those two terms, but they actually come together because in order for a deregulated utility or a resource aggregator or developer to deploy capital for that behind-the-meter storage that you might aggregate into a virtual power plant or that you might dispatch to prevent a constraint from being violated on your distribution system, there has to be a business case there. I mean, we have really worthwhile goals around decarbonizing the system and doing things that have great societal benefits. But at the end of the day, for this to be a mainstream business that works in a lot of different places, you have to be able to make money doing it. You have to have a return. And as there are a lot of carcasses on the wayside of this progression, I co-founded one of them, and you find that you deploy these assets, and if you have too much merchant exposure, as I did with a previous project, or if you have you don't have some vehicle to reliably monetize the asset, well, you're not going to deploy it, or you're not going to be around for very long. So that's where the DERMS and the VPP kind of support each other. The VPP side of it is, I don't care about the wires. I'm going to solve for maximizing how much revenue I can make in this market, whatever structure the market takes. The DERMS side is, well, I don't really care about the money necessarily. I care about, I need to increase hosting capacity, or I need to solve some other electrical engineering problem with these non-traditional resources. But I don't own the resources necessarily, and I need to come up with a mechanism to buy that capacity from them. And it sounds pretty straightforward. I mean, conceptually it is, but to actually transact that, you need software to make it happen, on both sides of it, right? So you could, in theory, you could have somebody with a utility with an AutoGrid DERMS and an aggregator with the AutoGrid VPP, and they could talk to each other, right? Where the DERMS is going to say, all right, I need to solve for this congestion relief problem, and I'm going to dispatch these groups of pools of resources that are made out of DERs, and the VPP is going to make that happen. It's going to reserve that capacity while respecting whatever other constraints you put on those resources, or whatever other revenue streams you're trying to capture. And again, it's critical that those pieces all fit together, otherwise you can't make money doing it, and then you won't have deployed the resources in the first place. Scaling this stuff is really the grail, or the thing that will be unlocked by that.
You said grail, one of the buzzwords for this industry.
Oh!
Holy grail, missing link, silver bullet, there's a ton of them. Anyway, Jason, what are your thoughts on kind of the definition of DERMS and VPP, and how it's also influenced LADWP's business model as you build toward that kind of replacing generation you talked about earlier?
Yeah, so I mean, you mentioned business model. We own or control most, if not all, of our generation. We have very little market exposure, power purchase agreements, long-term, we have buyout options. And so when you think about that structure, and you think about what our near future is going to be, we don't have that competency managing distributed resources like a lot of other utilities do, particularly in California, investor-owned utilities that have had reliance and build the skill set and the systems in place to be able to manage distributed resources in a way that allows them to match supply and demand. We just simply don't have that competency. But given our plans to not repower, we've recently expanded a lot of our efforts on distributed resources. We're in the midst of scaling up our feed-in tariff solar program, where we're actually going to add potential controllability there as well with energy storage. We're ramping up our demand response program as well. So we're going to do a smart thermostat program that'll launch next year. We're doing a smart charging program. So we've got all these programs and initiatives and all these pieces coming together, but we don't really have a vision yet and a system that's being deployed right now to control all of that. Now, think about taking all those pieces, bringing them to grid operators who have spent their career working in a vertically integrated utility where they have direct control over all of their tools, and saying, hey, I've got 5 different proprietary DERMS from 5 different companies. So what we need to do is, so in parallel with all of that, we started our distributed resource planning efforts to actually frame what that is actually going to look like. So I think in the near term, it'll probably be very, very basic control, being able to dispatch capacity and control these resources. But it's going to have to also include building the skill set to be able to actually do that. We also don't have advanced meters, so we don't have an AMI deployment. So we're one of the larger utilities that don't have that. So when we talk about doing a smart thermostat program, how do we do that in a way without validating or having a very robust validation of that performance? So that means deploying limited AMI at the same time. We're also doing a distribution automation effort right now to start to build the backbone and the fundamental systems and the visibility and the situational awareness to be able to make that happen. So I think that most other utilities might have come at it in the more traditional planning perspective, whereas we're moving forward with these efforts. We're doing all these things that I talked about and a whole lot more. We recently just advertised a DER RFI, and so it's very, very generic. We're going to get a lot of different proposals that come in. And we're also working with our planning folks, and we brought in some partners to help us identify the capacity needs on the different receiving stations throughout our grid. So with the information that we get from our RFI and the information on what we need at our different receiving stations over the next 10 years, we're going to start to advertise probably a large number of RFPs over the next year or two. So for those in the audience that have interest in doing business in that space, there's going to be quite a bit going on in Los Angeles over the next few years, and we have a long way to go in a short amount of time. So compare us to other utilities. not only do we not have that same expertise yet, but you can almost argue that we're going to have that, and the need for us to have that is even greater than other utilities. So I took us off on a really big tangent there because we're obviously really excited about it. And then you fold in other initiatives from, again, we're a municipally owned utility. Our mayor has set very aggressive electrification goals, electric vehicle goals. So at the same time that we're trying to manage the load that we already forecasted, we may have even more load than we had historically planned for. So there's a lot going on, and as you can see, we just don't have that fundamental system in place to be able to do that yet. But we're getting there, and it's going to be let me take a step back. I said all that a couple months ago for a talk, and somebody said, "Wow, you're making it really sound like working for a utility is a disaster." And I said, "Yeah, I actually would have never thought that I would have had the opportunity to work on so many of these different challenges at once." So I think once you put that perspective on it, it becomes a lot more exciting and a lot less overwhelming.
Definitely. And actually that dovetails quite well, Jason, with kind of the next piece I wanted to get into, which is the policy or regulatory piece. So it's great to talk about all these different, software stacks and different, types of resources we can bring online to meet challenges, but how is kind of the policy framework set up to allow for these opportunities? And are there any kind of barriers you see that need to be revised before you can implement these initiatives?
Well, in theory, you'd think that municipally owned utilities could move faster than, investor-owned utilities in California. We're governed by our board. It's appointed by our mayor. We also have very major decisions, either validated or approved by our council as well. So very high dollar amounts, very major strategic things would be brought to our council. So you'd think that we'd have the ability to be very, very nimble. But on the other hand, we're also, a utility, and utilities often don't move very, very fast. We're also structured like a city department. So you add in the sort of civil service aspect of it, which has very, very, the merits of that are very, very good. But on the other hand, we might need to bring in expertise fast, right? We may need to bring in some experts that have deployed DERMS before, that have experience integrating these things, rather than bring in somebody, train them for a number of years, and have them run programs like that. So on one hand, in theory, we can get things done on the policy side, get programs approved quickly, get funding quickly. But then when you bring in that expertise part of it, that's where it gets to be a little bit of a challenge, and it makes it a little bit tough for us to move fast.
Mm-hmm. And Takanori, I'd love to hear from you kind of what's the contrast with the Japanese market in terms of policy? I mean, how are regulatory frameworks set up there to enable these opportunities versus what we've heard about kind of on the US side?
Okay, sure. So in general, so biggest difference is Japan has a single regulatory framework. So in USA, so 50 states has 50 regulatory frameworks. So and the consumption volume of Japan is very big. So about 1,000 terawatt hour, 4 times than California, and 2 to 3 times than Texas. Very huge markets. So yeah, there are very big potential of the marketing. So about regulatory framework of the dams, we are now rebuilding the regulatory framework actually. So we hope to make the business environment more friendly to you and or many vendors. So actually I'm now visiting scholar of the Stanford University. I'm learning about the USA's cutting edge discussion, and we would like to try to assimilate such new regulatory framework to Japan now. So.
Great. And I feel like, Adam, you're kind of the perfect bridge between the two, because I know AutoGrid has done projects both in the United States and in Japan, and you're seated right in the middle as well. So could you kind of tell us a little bit about your experience between those two different markets?
So You know, that's good timing, because we just put this press release out a few days ago about this gigantic VPP project that we're launching with our customer ENERGIS in Japan. So this is actually, I think, a nice case study in how one way that the regulatory environment driving a business opportunity can work. So the Japanese different departments that define these things and critically define funding to pilot and then roll out these types of initiatives create an opportunity that we actually have more than one customer doing, but the larger one is ENERGIS, where they started a couple of years ago doing what I would call a progression from a more, not simplistic, but sort of binary demand response into more of a virtual power plant set point based system to provide capacity, then reserves, and eventually it'll get into regulation and all that with distributed energy resources. And the AutoGrid platform, well, that's what it does. So we've had scales in hundreds of resources in pilot scenarios in Japan doing precisely that. And the system that we're standing up for ENERGIS is going to scale into the tens of thousands, just because that's the business case that supports it, and that it makes sense at that scale, and maybe even larger than that. In the US, it's a patchwork, and it's actually a complicated enough patchwork. I love this idiosyncrasy in a sort of a way that you love something that's weird, not good, right? So I'm from New England, I live in Vermont, and in ISO New England, we've had rules that let you do some pretty cool stuff with DERs for years. So I was bidding a fleet of big variable speed pumps into the ISO New England frequency regulation market in 2012. Well, we don't need FERC Order 841 to do that, but the problem is that you're merchants, so you might make $2 an hour if you do that. I mean, it's like there's no business case there, right? So it's the left hand doesn't know what the right hand's doing with some of that stuff. And if you do crack that nut for one market, you figure, all right, I've got it figured out, figured out the infrastructure, and I can make it happen, and but now, and I can make it pay, but then you go over the border into New York, and it's completely different in New York ISO. So the AutoGrid perspective on it, though, because we're the shovel that people use to dig these piles of money, hopefully, out of this DER gold mine, is we see you see the shovel working in a lot of different places. So we have customers in the U.S. who are more on the DERMS wires side, so they might they'll feed some DNP3 analogs into the system that represent current or apparent power through a transformer or a feeder or something, and they'll do anything from more old-fashioned DR, hitting load control switches, or more modern things like thermostats, or send set points into a battery based on that objective function, holding that load below that level. But that doesn't, outside of a utility pilot, that doesn't necessarily pay across the board. It does in some specific pockets, like that's not one-to-one mapping, but that's very similar to what the Con Edison BQDM mechanism was all about. And there's some real money there, but it's just that one area, and it is a year-by-year auction, so you can't necessarily finance a big business case around that. So that's been our perspective.
For sure. So we're getting a lot of great questions from the audience. Some of them are quite specific. So actually, the first question here is for Jason. Why wouldn't LADWP use transmission to bring renewables from outside the region rather than trying to match local generation with backup storage?
Yeah, fantastic question. I won't know the detailed answer to that until we finish what we're calling 100% renewable energy study that we've partnered with NREL on, that we're planning to finish next year. I can tell you that in the preliminary studies that we've done to date, I mentioned earlier, we need probably in the ballpark of 1,800 megawatts of local, we call it in-basin energy storage. That's just the distributed resource part. We also are going to have to grow our utility scale renewables significantly. We just signed, or we're actually close to signing, a power purchase agreement for, I think it's 400 megawatts, 300 megawatts storage, and I think 1,200 megawatt hours. And this plan that we're putting together will probably include about 200 miles of new or upgraded transmission just in or near the city of Los Angeles. So when you think of anybody here that's done transmission development, you know that there's a very long planning process. There's a lot of risk of failure. There's a lot of risk of increased costs. There's a lot of risks of potentially reducing the size or the scope. And so when you think about solving the problem that we have of the lost 1,600 megawatts of base load, it is absolutely not just distributed resources. But there's also risk on that side too. We don't have, I mentioned this a couple times, we don't have that expertise. We don't have those systems built up yet. We're going to need to do that. And there's also risks there. And then we've got the risk on the transmission side as well. So we're very likely going to have to go full speed down both directions, recognizing that we're not going to get everything that we're trying to get on the distributed resources side, and we're absolutely not going to get everything that we're trying to get on the transmission side. But we don't have those 1,600 megawatts of natural gas to use after a certain time. There's a time where we cannot use them any longer due to state regulations. So this is a very, very big challenge that will not just be distributed resources. It will be very much so also a large-scale generation. So there's going to be opportunity for kind of almost every player in the market here. And it's going to really take a rethinking of the way that we rely on resources as well, where we need to build a comfort level working with a lot of different private sector folks. We need to think about the strategic implications of having multiple different partners. We need to think about, somebody talked about cyber risk before, and the hesitance to put such critical resources, especially as they grow in size and scope and we grow in dependence on them, to put them in a cloud. Well, the concern there is, with the cyber risk is a real risk, but then your solution can't just be, let's bring everything on site, because then you're trading cyber risk for operational risk. So, I mean, there is just a massive amount of things for us to really think through in a short amount of time. But that all said, we're not waiting. We're still standing up new programs. We're still, putting out new opportunities. And our hope is that as we're putting all these puzzle pieces on the table, we, at some point, we hand ourselves a map of what that, puzzle looks like, so we can start to put it all together in a way that makes sense. So I don't even remember the question. Oh yeah, transmission, yeah. I hope that answers the question.
Yeah, I think that was
okay.
That was a great response. Excellent. So another very targeted question we got from the audience was for Adam. Someone was asking if you could speak about your recent partnership with Schneider, and to give that kind of, a deeper tie to our discussion, how does your partnership with Schneider inform your, DERMS VPP integration that you discussed?
Well, it makes it better. So the DERMS is not an ADMS. So to get into the weeds of that a little bit or unpack that. So if you're, historically, you'd manage your distribution system by, figuring out, all right, I've got to account for this much load, the power only goes one way, and I don't really have to monitor it. In fact, I don't even know if it is out sometimes. I have to wait for my customers to call me, and you have this progression where you start monitoring some of this stuff, but as we've heard in a lot of other sessions here in the last 2 days, it's not even today always the case. And I still hear ridiculous stories from customers like, oh yeah, we send a crew out. Every 6 months, they go and they look at the little sweep arms on the ammeters in the substation, and they call the numbers in, and we say, wait, it was how high? No, that can't be right. And so that's like where you're coming from with this. So then, okay, if you're going to account for two-way power flows, you're going to account for the system to be much more dynamic. You can reconfigure it in different situations where, again, you're injecting power in the middle of that network of circuits that you're reconfiguring. Now you really have to have visibility and intelligence in that, so that's what an ADMS should give you. And Schneider has a very good one, so it's just going to do state estimation around what does the AC power flow situation look like in this reconfigured state. But then it's not as simple as, well, the power is going in here now instead of here, and there's this much load instead of this much load. No, there's these generators or solar generators might come back on after 5 minutes if they tripped, or they might not. And that's going to change my power factor or voltage in this way or that way or whatever. The DERMS is the thing other than the cap banks and load tap changers that the ADMS can look to say, help me out. Okay, you've got a fault on your system, you've isolated it, you've reconfigured it, and now your 26 kV circuit's running at 20 kV, and you're like, well, do we just take the whole area down, or do we try and find a solution here? The DERMS is that solution, so it can give the ADMS optionality on, well, okay, so you asked about all of these resources that I've tagged with these wire segments and these feeders and these transformers or whatever, and the AutoGrid system came back and said, you've got this much flexibility for this period of time in that area, and the ADMS can say, dispatch it. And that, in an ideal world, is how that's actually going to work. And in reality, that's, I mean, that's jumping in head first into this, right? So it's maybe a reason to do some steps through pilots and get moving with that. But those have been happening for a few years now. AutoGrid's had a number of them going in different parts of the country and overseas. So that's, I think I did remember the question, so maybe I'm, so getting back to the Schneider ADMS piece, that's the high level inner workings of what the DERMS does for the ADMS, and yes, we announced the Schneider partnership, but you know, anybody, to make this a little bit more academic, anybody's ADMS, as long as it can talk to the DERMS, and vice versa, could in theory do that.
Yeah, about Schneider, so Schneider recently joined the Japanese market about the microgrid. So yeah, recently a big outbreak happened in Hokkaido. So the resilience is a very hot issue in Japan, so Schneider feels a business chance to join the Japanese market, I'm feeling. So at first, in Japan, there are many isolated small islands. So some small microgrids utilizing some dams or something like that will diffuse at first in the small islands, I'm feeling. So maybe in the few years, in the next few years, some new projects or some new customer will happen. So in Japan, I feel.
So we've been getting a few questions here kind of about resource mix. So a few talking specifically about, you know, coal and how that's factoring in, some mention of how the EPA replaced the Obama admin, you know, plan to close down coal-fired power plants today. And so I'd love to hear each of your perspectives on how, you know, virtual power plant technology can enable a shift to a more kind of clean grid overall. Does anyone want to jump on that one first?
I'll start because it builds on the ADMS piece. So the way you use a DERMS to support an ADMS to solve distribution system problems, likewise you can use a VPP to give the bulk transmission system or the bulk electric system, which was accepting the power from those dirtier plants and has now got to get it from somewhere else, options. So the VPP can say, hey, I've got this much flexibility in this sublab or this zone or this node or however you have your system and market structured. I can ramp it, I can in this amount of time, or I can respond to a price signal. I can give you an energy curve, a price curve, the way a traditional unit can. So it is truly a virtual power plant. And in that way, you can replace those baseload units with flexibility. Now, that's kind of the ideal situation. The devil's always in the details with these things. So you get into, well, what do you do about the loss of inertia that those units retiring or coming off the system will create? What do you do with some of the VAR support problems you're going to have if you, especially in parts of the country of long transmission lines? Somebody asked a question about repurposing turbines yesterday to solve that problem. That's a thing. People do that. It's synchronous condensing. So the VPP is not the only solution, but it's one of the more flexible tools that the system operator can call upon to work around the fact that you're losing those units.
I think for LA, I think at a minimum, everything that Adam mentioned is going to be a key piece of what we would need to use them for. I would say in addition to the constraints that I talked about, not being able to bring in bulk power, we're limited by the way, the geography of Los Angeles. We can't lean on neighbors to the west because that's the Pacific Ocean, right? We don't have the ability to do that. And we have some, physical limitations of bringing power in from the south. So not only is it for all the reasons, voltage support, as a potential alternative to rotating mass and things like that, but also managing resources that we need to replace, that serious amount of capacity that we're about to lose as well.
Takanori, any thoughts on the case?
In Japan, Yeah, VPP will replace some thermal power plants. Maybe at first oil thermal plants. So there are still oil thermal plants in Japan. So but they are very old. So the virtual power plants will replace some peaker of the oil power plants. And a second is maybe natural gas thermal plants. The coal thermal plants is difficult to adjust the supply. So in Japan, we are using natural gas thermal plants as adjustment supply equipment. So about the coal, Japan is in the very severe situations because there are no natural resources. There are few natural resources. So the diversity of the supply is very important for the energy security. So coal power plants is still important factor of the energy security. As we import coal from Australia, from Indonesia, very safe sea lanes. So, but at the same time, we are now developing some carbon capture utilization and some storage or something like that. So we will try to keep coal thermal plants at a certain level, but at the same time, we are now making some markets, inverse markets or something like that. So if virtual power plants, the economic efficiency, economic performance will improve or some, that's the power of the market. So the virtual power plants will replace some more and more thermal power plants, I think.
Quick follow-up from the audience on that, Takanori. Someone was asking about, how is it possible to get the most out of battery electric vehicles as well as renewable technology if Japan is still investing fairly heavily in not just coal but also hydrogen resources? Do you see that as a risk in kind of betting infrastructure being between the two rather than just going kind of whole hog on electric?
Okay, so the answer is we are investing in many types of technologies, including hydrogen. So hydrogen is very important to decarbonize the manufacturing, like iron manufacturing or some chemical production or something like that. And some mobility and some thermal power plants utilizing hydrogen is one of the options. But this is the problem of the competitiveness, economic competitiveness between hydrogen and electrification. So we are still developing both technologies. But I'm not sure the future.
Gotcha. So we're kind of coming towards the end of the panel, and I'd love to ask a question to kind of wrap up the discussion and think ahead. So let's say hypothetically we were sitting on this stage talking about this same subject of DERMS and VPPs in maybe 5 years, or maybe if we wanted to kind of align with LADWP's 2029, right? Is that right? Yeah. Goal? Say we're sitting here in 10 years. What do you each think will have shifted in the energy space with regards to these technologies? What would we be talking about on stage then?
I'm going to look over to Adam.
Well,
I will say that it would probably be the longest panel that has ever been conducted. But aside from that.
I think you're going to, you'll see a lot of these things that are in pilot or in limited scale now be rolled out. But what's going to enable that is going to be being able to actually communicate to the devices at any scale. So you have tariffs now sometimes where you have to, and California Rule 21 is going to drive a lot of this, and the Australia, New Zealand 4755 code is pushing similar things there, where the devices have to be able to communicate, to be able to talk to them. And that's all fine and good. It solves these problems in theory, but by then, you're going to have seen crossing the chasm where you actually have to have started doing that, or you will not be able to operate your system anymore. So I get customer feedback that, I'll say, how bad is it, these hosting capacity issues? They say, well, from a planning standpoint, it's really bad. We've got an interconnection queue that's 3 times our peak demand or whatever. In some parts of the country, you see that type of thing. Okay, well, that's bad, but there's really no DERMS solution to that. You just need more wires if you're going to really go at that scale. Because the places where you can put the solar panels are not, or the wind turbines are not where the load is, so you need infrastructure there. But from an operational standpoint, once it's actually connected, it was interconnected for a given configuration of the system. And when you go outside of that configuration, you are either running with scissors if you don't have a power flow model for what is going to happen when you reconfigure it, or you need, if you do have that model, you need some sort of tool to have that solution be acceptable, to say, all right, well, I need to have shed this much load to operate in this reconfiguration. And I mean, again, I'm a Northeasterner, so I'm used to above ground wires that have trees falling on them all the time. All the time. I mean, even a sunny day with no wind, a tree falls down. Like, what? Really? Anyway. But every time that happens, you either have an outage or you have to reconfigure around it. And if you have this really heavy penetration of DERs, that doesn't work unless you can talk to them and say, okay, you there, I need you to ride through in this way. You there, I need this, your volt-watt curve to look different. I need your volt-var curve to look different. I need to, and that has to work. It can't be a science experiment. It can't be a tinker toy. It has to, that's going to be at scale and in heavy use, I think.
Yeah, I don't know what it'll look like in 10 years. I would look to the industry to, provide solutions for us. Utilities, probably innovate a little bit less than the private sector on that front. I will say that the question earlier about hydrogen versus electrification, and the point that I made earlier about risk on the transmission side versus risk on the distributed resources side, all of this means that we're going to have some lost investment because we don't know what that future is going to look like. We're going to have to pilot programs. We're going to have to deploy sometimes physical assets, and this is going to be an expensive transition. And from a utility perspective, especially a municipally owned utility, when it comes to managing and trying to do this in a very thoughtful and cost-effective way, that becomes really important for us because Los Angeles is a very diverse city. We've got a lot of wealthy folks, but we have a lot of folks that are not wealthy. And so to the degree that we can transition over the next 10 years to less gas, and in our case, quite a bit less gas, and a higher reliance on distributed resources, we've got to do it in a way that is cost effective and minimizes the impact to rates. There almost certainly will be rate increases, but to the degree that we can try to identify ways that are, what are our quick win investments? What are our no regrets investments? Those are the things that we need to get started on now. And historically, we've not been ashamed at some points as being a fast follower, seeing what other utilities do and saying that worked, we're going to do that now. Now we're going to have to get out of our comfort zone with that a little bit and start to innovate. And so, what is that going to mean for stranded investment? What is that going to mean for rates? That's going to be a really big consideration for us as well.
Great. Takanori, any final thoughts on kind of the future trajectory of DERMS and VPP?
Yeah, we hope the DERMS and the virtual plants will be more familiar and more popular in Japan and in the world. So we would like to cooperate with many companies and many university research institutes. So maybe we can support some projects and some initial markets or something like that. So so it is very important to decarbonize the future. So yeah, the dams and the virtual power plants will be succeed in the future, I think. Yeah.
Great. Well, please join me in thanking our panelists for this excellent discussion.